Hey, Ethan here. Today I'm going to talk about acetylcholinesterase inhibitors. And before I begin, I just want to say I'm going to mispronounce that acetylcholinesterase word a lot in this, so I apologize in advance. And the second thing, before I begin, I want to tell a story because this topic reminded me of something that happened when I was a kid. When I was a kid, I'll be honest, I got a lot of colds, as kids do, and I hated them, understandably. So I got to thinking, because I was a curious, enterprising, overconfident kid. I said, I'm going to solve this cold problem. And what solution did my young, dumb mind come to? Solution in my mind was clear. Solution was hand sanitizer. And before I go any further, I want to make something crystal clear. Do not do anything I'm about to tell you about. Do not ingest, inhale, or use hand sanitizer anywhere except your hand and skin. It can be very dangerous. These FDA warnings should be proof of that. So with that disclaimer aside, what did I think about doing? Thank goodness I didn't actually do it. My plan was pretty simple, right? Let's say I got a cold. I would inhale or ingest hand sanitizer because, again, the label on hand sanitizer bottle says it kills 99% of germs. And, because mom told me germs cause the cold, hand sanitizer should be able to kill the germs that cause the cold. And if the germs are gone, then the cold should be too. That means I should recover from the cold and I should go back to playing outside and having fun. The logic was irrefutable, or so I thought. The last thing I had to do before going through this plan was simple. I had to go to my mom and tell her. Thank goodness I did before doing it, because she was aghast and her response was emphatic. I don't remember exactly what she said. This is a paraphrase. Something along the lines of, no, 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 don't do it. Very dangerous. If you do it, no more Pokemon. That was enough convincing for me. The reason why I bring this up is because the mechanism of action of hand sanitizer reminds me, at least metaphorically, of acetylcholinesterase inhibitors. And like they both, in that they both act like chainsaws. They're non-specific. They're going to mow down everything in their path, right? Hand sanitizer denatures proteins. It will kill 99% of germs, and it will kill you too if you drink it. So just don't do it, right? It's dangerous. And the same sort of applies with acetylcholinesterase inhibitors in that they act on everything, and in doing so, may fulfill a therapeutic target. And when I say everything, they act on everything that acetylcholine acts on. And in doing so, this may fulfill a therapeutic target, but can also, unfortunately, cause collateral damage. So before I really go into it, I want to sort of preview what I'm going to talk about today. Before I talk about the inhibitors, I want to talk about what sort of acetylcholine does in the autonomic nervous system. I'm also going to summarize the action of the enzyme acetylcholinesterase, and then I'll finally be able to talk about the acetylcholinesterase inhibitor. So what is acetylcholine? It's a very important neurotransmitter seen here. It acts at 3 places in the autonomic nervous system. So it's going to act both in the parasympathetic and sympathetic nervous system at these ganglia, meaning the sort of interface between the preganglionic and postganglionic neurons, as well as it's going to act at specifically the parasympathetic nervous system's synapse directly onto its target organ. So where that postganglionic parasympathetic neuron synapses with that target organ, that synapse is going to involve acetylcholine most of the time. And it's also going to act at the neuromuscular junctions. So that's specifically where the somatic nervous system interacts with muscle fibers. So it's going to act everywhere. It's going to act all over the place. And I want to focus a little bit more on what actually happens at the synapse. So when we talk about the action of acetylcholine, again, I want to just reemphasize, it has a very, very broad action. Remember, it's acting all over the autonomic nervous system. The autonomic nervous system does a ton of things all over the body. And to be fair, the fact that acetylcholine acts at neuromuscular junctions means that, muscles are all over the body too. So it's going to act at muscles all over the body as well. So acetylcholine is acting all over the place. I want to make that very clear. But wherever acetylcholine acts, this is sort of how it operates. At a synapse, what's going on? Well, acetylcholine's made from acetyl-CoA and choline, and when it's released from the presynaptic neuron into the synaptic cleft, it really acts on 2 main types of receptors. The first are called muscarinic receptors. These are G protein coupled receptors, which means they sort of activate second messengers and do all sorts of stuff. And these are mainly found at the postganglionic parasympathetic neurons interface with their target organ. Again, this is just a mouthful, but just think about when that, parasympathetic nerve, that last piece before it actually touches the part where it actually interfaces with the target organ, that interface is sort of mediated by acetylcholine. And that specific receptor involved is usually the muscarinic receptor. And generally these are slow because the second messenger system takes time, or at least takes more time comparatively when you compare it against the nicotinic receptor that I've circled here in teal. These are ligand-gated ion channels, and they're found mainly at two places, neuromuscular junctions, as well as the synapses between the preganglionic and postganglionic autonomic neurons. Goodness gracious, these are all a mouthful. But in short, just again, nicotinic is going to act at the neuromuscular junction and sort of the intermediary between the preganglionic and postganglionic neurons and the autonomic nervous system. So not at the synapse on the target organ, but the one before that. And these nicotinic, again, are faster ligand-gated ion channels. But remember, when acetylcholine binds these receptors, it's not naturally going to just leave, right? It wants to stay. The only thing that's sort of taking it away in order to stop this chain of synaptic transmission is an enzyme. And we need to stop it because we don't want to keep things, constantly firing. And that enzyme is acetylcholinesterase. That's the action that's shown here. The breakdown of acetylcholine in order to stop synaptic transmission. That's where acetylcholinesterase comes in. So what is acetylcholinesterase? In short, it's an enzyme that facilitates a breakdown of acetylcholine into acetyl-CoA and choline, right? It does this action right there. And it's really important because we need to stop synaptic transmission at some point because acetylcholine is going to bind to that receptor and it doesn't want to stop binding unless you do something to it. And the something is acetylcholinesterase. So with all that said, I want to sort of review everything I talked about because there was a lot there. What is acetylcholine? It's a neurotransmitter that acts at the neuromuscular junctions as well as the autonomic ganglia, meaning sort of the interface between preganglionic and postganglionic neurons in the autonomic nervous system. And it also acts at the synapse at the postganglionic parasympathetic neurons as they touch their target organ. So basically, in short, it really acts all over the place. There are two major types of cholinergic. I don't even know if I'm going to pronounce that correctly. There's two types of acetylcholine receptors, nicotinic and muscarinic. Nicotinic are these ligand-gated ion channels found at neuromuscular junctions and autonomic ganglia. And you have muscarinic receptors, which are slower G-protein coupled receptors that are mostly found at the parasympathetic neurons postganglionic synapse. So that synapse where it touches the target organ in this parasympathetic nerve. And lastly, acetylcholinesterase, what does that do? It breaks down acetylcholine in the synaptic cleft in order to stop that synaptic transmission. Again, you don't want to keep these nerves firing forever, and that's the job of acetylcholinesterase, to break down acetylcholine so the action of the receptors stops. So that's the job of acetylcholinesterase, to stop the continued action of acetylcholine on acetylcholine receptors. So moving forward, when we talk about acetylcholinesterase inhibitors, I feel like the function is pretty clear, right? It's going to stop the action of acetylcholinesterase. So when we think about acetylcholinesterase, imagine just stopping that. So what is that going to do? Well, essentially this inhibitor, the acetylcholinesterase inhibitor, is going to phosphorylate the acetylcholinesterase enzyme, which is going to affect the ability for the enzyme to bind acetylcholine, allowing acetylcholine to remain intact and on the receptor, allowing that sort of synaptic transmission to occur. And in this way, remember, this happens, all over the body, as I've said many times, at the neuromuscular junctions, autonomic nervous system, all over. This is sort of where that comparison to hand sanitizer comes into play, and that it's non-specific. It's going to act in the autonomic nervous system. It's going to act on those neuromuscular junctions. It's going to act on all sorts of types of nicotinic, muscarinic receptors. It doesn't matter. It's going to act everywhere. And in that way, that's sort of why I thought of hand sanitizer. And hand sanitizer acts all over the place too. So really, anywhere acetylcholinesterase is used or acts, these acetylcholinesterase inhibitors will also be able to act as well. And the fact that it has such a broad, target function means that the side effect profile is probably going to be broad too. And if you really think about everything we've talked about, the side effect profile makes sense. So this is something I pulled straight from Wikipedia. And again, I'm not an expert. I'm not going to be able to tell you exactly the mechanism of action of each one of these side effects. But if we paint with broad brush strokes, this all sort of makes sense. So let's talk about this first set of side effects here. It says that actions of the parasympathetic nervous system are affected, and that makes sense, right? Why? Acetylcholine acts, again, at that postganglionic parasympathetic neuron synapse, right? So that point where the parasympathetic neuron synapse is the target organ, acetylcholine's acting there. If we inhibit acetylcholinesterase, then acetylcholine will continue to act, meaning that neuron will continue to fire. We're going to overactivate the parasympathetic nervous system. So just think, everything the PNS does, rest and digest, that's going to go into overdrive. That's what it explains bradycardia, slow heart rate, the rest part, GI tract hypermotility, the digest part of rest and digest, all that's going to be overactivated, and that sort of makes sense given the side effects. Cholinergic crisis and actions of the neuromuscular junctions, these both relate to acetylcholine's effects on the neuromuscular junctions. So again, you're going to have muscle issues, which makes sense. So acetylcholine's operating. I don't know about this one. I'm gonna be honest. Neostigma. I'm not gonna even talk about that. And lastly, hyperstimulation of nicotinic and muscarinic receptors. Again, that makes perfect sense because acetylcholine is going to stay bound to both types of receptors because acetylcholinesterase isn't breaking it down. So it's going to be hyperstimulated. So that all makes sense. But if you're like me, you might have a question. There was a lingering question when I was reading this and making this video in that, okay, we talked about neuromuscular junction, parasympathetic nervous system, but hold on. What about the sympathetic nervous system? What about those nicotinic receptors at the autonomic ganglia, right? Because hello, I thought acetylcholine acts right here on the sympathetic nervous system. And you would be right, or that acetylcholine does act there. And the question is, will acetylcholinesterase inhibitors also affect action there? I'm not an expert. The truth is that these inhibitors actually have a much more complicated act and function and effect, much more complicated than at least what I've been talking about. Again, I can logically deduce well, the side effects make sense, but I haven't, explained at all the actual mechanism by which those side effects occur on the different nerve cells and stuff. So again, it's complicated, but I did, some cursory research and I could immediately just find a study where, the study looked at a cholinesterase, so that's a broader category of acetylcholinesterase inhibitors, cholinesterase inhibitor, and, conclusion, boom, administration of this inhibitor did induce sympathetic nervous system activation, which again, would make sense given acetylcholine's role in the sympathetic nervous system. But I want to be very clear. Everything I've talked about here is an oversimplification, right? As this paper's abstract says, the effects of these inhibitors on the autonomic nervous system are complex and controversial. So just remember for sure what I said about mechanism. When it comes to side effects, that's more a thought exercise rather than something you should take verbatim. So what did I talk about today? Couple of things, right? Acetylcholine, very important neurotransmitter that acts all over the nervous system, neuromuscular junctions, autonomic ganglia, postganglionic parasympathetic neuron synapses. What is acetylcholinesterase? Well, it breaks down acetylcholine in order to stop synaptic transmission. And lastly, acetylcholinesterase inhibitors stop acetylcholinesterase, which thereby continues synaptic transmission and mainly has effects in the PNS with muscle function. So again, don't be fooled by the inhibitor role. In reality, you're sort of overactivating the role of acetylcholine because you're stopping the role of an enzyme that would break down acetylcholine. So again, that's all I have for you, acetylcholinesterase inhibitors. I hope you learned a little bit. I hope this was a little engaging, entertaining, and perhaps educational, or perhaps on all three of those. But here are my sources. And again, wish you the best. Hope you're well. Take care and have a good one. Bye-bye.